In this video, we're going to look at the first lot of organic questions, the multiple choice section. So questions 1 to 4 were matching the description of the reaction to the type of reaction occurring. Question 1, conversion of propan 1-ol. So we have a primary alcohol going into an alkene. So that is removing water, because if I have primary alcohol such as propan 1-ol, then to turn that into propene, I would need to remove water in order to make the double bond in between them. And so that A1 would be a dehydration reaction. So that would be D. Number 2, conversion of 1-chlorobutane into butan 1-ol. So there's no change in the position of anything. We are just changing a chlorine into an OH group using potassium hydroxide. So that is a substitution reaction, which is B. And that's because I'm just substituting the OH group where the chlorine was. Number 3, reaction between but-2-ene and hydrogen bromide. Well, that's going to be an addition reaction because it's an alkene reacting with HBr. And then number 4, conversion of propanoic acid. So we're going from a carboxylic acid into the equivalent alcohol. So we're reducing the amount of oxygen, adding more hydrogen, so that would be reduction, which is C. Question 5, again, just type of reaction, making 2-chloro-2-methyl-propane from 2-methyl-propan 2-ol. So it sounds very complicated, but actually the 2-methyl bit is the same for both of the molecules, and really you're just going from chloro to an ol, so you're going to an OH group from a chlorine, and the only type of thing that can be happening there would be B, nucleophilic substitution. Okay, number 6, which particle could act as an electrophile? Well, an electrophile needs to accept a pair of electrons and be attracted to an area of kind of electron density. So ammonia is definitely out, it has a lone pair, it has an excess of electrons. It's going to be B because boron trifluoride has that space there where it can accept a pair of electrons from a double bond. Chlorine there is a free radical because it has 7 in its outer shell, so that is a chlorine atom. And D is a sodium atom, which is not, again, never going to accept electrons. Sodium, it's definitely going to be something that loses electrons in a chemical reaction. And then for 7 to 10, we've been given some structural formulae. And what I've done is I've not written the whole displayed formulae out, but I've tried to simplify the structural formulae or show them a little bit more clearly. And so what I did there for A was I went along where I saw a CH3, CH2, that's obviously just a straight chain. When I see a CH, that's a clue that there isn't simply one bond to the next carbon, that there's something else going on like a branch. And I see CH3 twice. CH3 cannot join to another CH3 and another carbon at the other end. And so that means there must be a branch in the chain. And if I look at it, this carbon now has the correct number of bonds, 1, 2, 3 and 4 for the hydrogen. Drawing out B, I've had a methyl group and a CH2, then I had 2 consecutive CHs. So there's not enough hydrogen there for each of those carbons to just have single bonds around them. That's where there must be a double bond present. In C, we have 2 CH3 groups in the middle, which means we've got a carbon that has methyl groups attached to both of its kind of spare positions. And then in D, I've got a CH3 there, which is clearly a branch because it's not at the end of the chain, and I have another CH3 here. So there are 2 methyl groups in D. So that makes it a lot easier to sort everything out. So 2,2-dimethyl, I need both of the groups on the same carbon, propane, 3 carbons in a row. That would be C. 2-methyl butane, that would be A. There are my 4 carbons in a row. Second carbon, methyl group coming from the second carbon. 9,2,3-dimethyl butane, that would be D, because we have both of those methyl groups there. And pentatoluene would therefore be B, because the double bond starts on the second carbon.